Welcome to The Explainer. Today, we're going looking for the ghost in the map, that invisible layer of data that turns a simple picture of the world into something way, way more powerful.
Let's just dive right in. Think about the last time you used a map on your phone. You tapped on a park or a restaurant, and boom, a whole bunch of information just appeared. But have you ever really stopped to think about how the map knows all that stuff?
It seems like a simple question, right? How does a map know a river's name? I mean, it knows where the river is, obviously, but its name, or how long it is, or how many dams are on it, that's where things get really interesting. So here's the secret. The information that powers your map isn't just one single thing. It's actually made up of two totally different but deeply connected types of data, and they have to work together perfectly. Think of it like this. On one side, you've got your spatial data. That's the where. It's the coordinates, the lines, the shapes that show you where the river physically is on the planet. But then you have the non-spatial data. This is the what. It's all the juicy details, the attributes, its name, its length, all those facts about the river. And when you combine those two, when you link the where with the what, you get something called geospatial data. This is the absolute foundation of any geographic information system, or GIS. It's what gives a map its brain. Okay, so we've got all this incredibly useful descriptive data, but just having a giant pile of facts isn't enough, right? A jumble of numbers and words is just, well, a jumble. So how do you turn all of that into something you can actually use? First, we gotta get one thing straight. There's a huge difference between data and information. Data is just the raw stuff, the facts and figures. Information is what you get when you take that data and you process it, you give it structure, so it actually means something. It's all about organization. For example, take a look at this. Ward 14, 2431, 645, an amount in rupees. What on earth does any of this mean? On its own, it's just a random string of facts. It's data, for sure, but it's not very helpful. It's basically digital noise. But watch what happens when we give it some structure. We take those exact same facts, but now we put them in a table with clear headings. And boom, it all clicks into place. It's not noise anymore, it's information. We can see instantly that Ward 14 has a population of 2,431. That simple act of organizing everything changes the game. And the powerhouse tool we use for all this organization is the database. You can think of it like a massive, super smart digital filing cabinet. It's designed to store, manage, and share huge amounts of data efficiently. It's the engine that turns all those raw facts into knowledge. Now, just like buildings can have different blueprints, databases have different ways of structuring all that information. These are called models, and they're basically the blueprints for our digital filing cabinet. One of the early ways they did this was with the hierarchical model. It's easy to picture. Just think of a family tree. You have one parent at the top, and it can have lots of child records branching off. But, and this is the key, each child can only have one parent. It's a very strict top-down structure. Then came the network model, which loosened things up a bit. Instead of a rigid tree, it's more like a web. In this model, a child record could have multiple parents, which allowed for much more complex many-to-many connections. It's a lot more flexible. But the one that really won out, the one that's pretty much everywhere today, is the relational model. It does away with all those complicated trees and webs. Instead, it just organizes data into simple two-dimensional tables, just like the one we saw a minute ago. The real magic is how you can link these simple tables together. It's incredibly flexible and super efficient. And that's why it's the foundation for almost every modern database you can think of. All right, so we've got our data, and it's all neatly organized in our relational database. That's great. But how do we actually talk to it? How do we get the answers we need? I mean, when you search on your map for, say, rivers longer than 500 kilometers, you're basically asking that digital filing cabinet a question. But you can't just ask it in plain English. You need to speak its language. And that special language is SQL, that's SQL, which stands for Structured Query Language. It's pretty much the universal standard for talking to or querying relational databases. It's how we tell that filing cabinet exactly what to go find for us. And at its core, a basic SQL query is actually pretty simple. It's almost like a sentence, and it's built around these three key commands: select, from, and where. Here's how it breaks down. You select the specific pieces of information you want to see, like the river name.
You tell it which table to get that information from, like the rivers table. And then you specify the conditions it has to meet using where, for example, where the length is greater than 500. It's a super precise way to ask for exactly what you need.
Okay, let's zoom all the way back out. We started with a simple question about a river on a map, and we've gone on this whole journey through data structures and query languages. So what does this all mean for the map you use every day?
Well, here's the big picture. Every smart map you touch is really two things working together: the spatial data, the where, and a whole universe of non-spatial data, the what. All that what data lives inside these enormous, highly structured databases. And every single time you tap, search, or filter something on that map, your phone is sending a tiny SQL query to that database to pull out the exact information you asked for.
And that is the ghost in the map. It's not just a picture of the world. It's a dynamic, living interface to a massive, organized brain. It's this invisible, highly structured layer of data that transforms a simple map into an incredibly powerful information system. So the next time you use a map, just take a second to remember that elegant system working behind the scenes. And here's a final thought to leave you with. Now that you know it's there, what other hidden layers of data do you think are out there, quietly shaping your world?